Okay, last class we completed photoelectric effect. Let's do some basic numericals, people, on photoelectric effect. Before we directly jump into the numericals, can someone give me what was the photoelectric equation? Excellent. H nu is equal to H nu naught plus half mv squared. ठीक है, एक्सीलेंट बोलना पड़ता है. Chalo, let's discuss the first question, people. It says that a photon of wavelength 3000 angstrom. So instead of frequency, they've given us wavelength. Photon of wavelength. So this is this, people, nu or nu not? Excellent. That is nu not, because pardon me, it is nu, because that's the light which is going to be incident on the metal. 3000 angstrom. How much will that be in meters? 3000 into 10 raised to minus 10 meters. Send acid. ठीक है, or we can write this as, people, 3 into 10 raised to minus 7 meters. Strikes a metal surface having work function. So what was work function? Phi. How much have they given that as? 2.2 electron volts. I need that in joules. How do you convert electron volts to joules? 1.6 into 10 raised to minus 19. तो वो joules में convert हो जाएगा. Okay. What do we have to first calculate? The energy of the photon. What is the formula, people, for energy of photon? Excellent. That is hc by lambda. How much is h? 6.626 into 10 raised to minus. How much is c? And how much is lambda, people? 3 into 10 raised to minus 7. Okay, I think you people can do the mathematical part of the question. साथ में भी हम करेंगे. What is the second part of the question saying? Kinetic energy of the emitted photoelectron. How do we find kinetic energy, people? What is the formula for kinetic energy? Now we cannot use half mv square, but we know that. Can I say kinetic energy is h nu minus h nu naught? Yes or no? Or I can write that as h nu minus the work function. Any questions over there? यहाँ से ही मुझे मिला है वो formula. h nu naught is work function, and this is the kinetic energy. Now, so kinetic energy will be equal to h into nu. I can write that as hc by lambda minus the work function. hc by lambda is the energy of the photon. उसका वैल्यू यहाँ से मिलेगा, and work function phi का value you'll get it from here. चलो, quickly calculate that for me, जल्दी जल्दी. So this is the value, people, that you should get for work function, and this is the value that you should get for kinetic energy. The third parameter that we have to find is the velocity of the photoelectron. How will we find velocity? Anyone? Using kinetic energy, that is correct. So we can say that half mv squared is, how much do we get the kinetic energy? 3.106 in 10 raised to minus, or can I say v square is 2 into 3.106 into 10 raised to minus 19 upon m. M is mass of the electron. Can someone give me mass of electron? Excellent. 9.1 into 10 raised to minus 31. Minus 31 goes up. That becomes 10 raised to 12. And what will this become? This is 3.1. This is 9.1. Can I say approximately? And 2 by 3 is how much? 0. But this is the value for V squared. We are looking for the value for V. V will be under root of 0.67 into 10 raised to 12, or we can say that V is under root of 67 into 10 raised to 10. 10 raised to 10 comes out, becomes 10 raised to 5. Under we are left with root of 67, and it will be somewhere around 8 square is 64, so somewhere around did you people get that? That is velocity. Let's move on to the second question. Question says a metal was radiated with light having frequency 4 into 10 raised to 12 Hertz. The electron emitted had kinetic energy twice the electron emitted when the same metal was radiated with frequency 10 raised to 13 Hertz. Calculate the threshold frequency. Obviously, a metal was radiated with light having frequency. So the first frequency that we have is 4 into 10 raised to 12 Hertz. And let's say the kinetic energy here is Ke1. The electron emitted had kinetic energy twice the electron emitted when the same metal was radiated with frequency. यहाँ पे frequency क्या people? 10 raised to 13 Hertz. And what is the kinetic energy? Ke2. Can someone give me the relation between Ke1 and Ke2? वापस से. So energy emitted of kinetic energy, the electron emitted had kinetic energy twice the electron when the same metal was radiated with this frequency. That means that Ke1, the energy of the first electron is twice Ke2. With me till here? अभी हमको पता है what is the formula for Einstein's photoelectric equation? H nu minus H nu naught is equal to kinetic energy. Metal same है, so threshold frequency भी same है. Ke1 I can write, यहाँ पे मैं H भी common ले सकता हूँ. Nu minus nu naught is equal to kinetic energy. So I can write Ke1 over here as H. Nu1 minus nu naught is equal to 2 times H. Nu2 minus nu naught. With me? H goes away. So nu1 minus nu naught is 2 times nu2 minus. Can you solve this and give me the value of nu naught. Jaldi jaldi. I can take 2 nu naught here minus nu naught is, and I can take nu 1 to the right. Therefore nu naught will be 2 into nu 2 का value is 10 raised to 13 minus nu 1 is 4 into 10 raised to 12, or this is 20 into 10 raised to 12 minus 4 into 10 raised to 12, or this is 16 into 10 raised to 12 hertz.
So I got that answer, but the frequency of the first one is lesser than the threshold.
For the second one, still electrons are coming out. Okay. Now look at the next numerical. If P is the momentum of the fastest electron ejected from a metal surface due to light of wavelength lambda, then for the momentum 1.5 P, the wavelength of light should be. Question thoda sa alag hai. What is the formula for photoelectric equation? In terms of lambda, we can say that Hc by lambda is equal to Hc by lambda naught plus kinetic energy. What's the formula for kinetic energy, people? Half mv square. ये formula है, ठीक है? This is also called as work function. पूरे formula में if we try to observe, there is no momentum, which means कहीं ना कहीं से हमको अंदर momentum लाना है. Also they've given us an assumption. क्या assumption बोला? Assume that work function is very small as compared to kinetic energy. Why have they given us this? Since the work function is very small, we can approximate this equation to Hc by lambda is equal to half mv squared. We can get rid of the work function term. कहीं ना कहीं से momentum लाना. What is the formula for momentum? Anyone? mv. I think you people get an idea. कैसे करेंगे mv इसको?
1/2 PV.
Can I say this is Hc by lambda is half mv square? Can I write that as mv square? I multiply by m and I divide by m. Kither tak with me? Hc over lambda is 1 by 2. M into mv square. Can I say this is m square into v square over m? Anyone who did not get that, क्या किया? 2m, I take it to the left. तो क्या मिलता है? 2 hc m over lambda is equal to m square v square. Can I write it as mv the whole square? And what is mv, people? Momentum. So 2 hcm by lambda is equal to momentum. Pardon me, momentum square. Is 2 a constant? Is h a constant? Yes. Planck's constant. C is also a constant. Speed of light. What is m? Mass of the electron. This is also a. Can I say the numerator is entirely? Or can I say p square is proportional to 1 upon or p1 square upon P2 square will be lambda 2 over lambda 1. Yes or no? क्यों किया ऐसे? If P is the momentum, which means P1 का value is P for the fastest electron ejected from a metal surface due to wavelength of light, lambda. So I can say lambda 1 was lambda. Then for the momentum 1.5 P. So now P2 is 1.5 times P. The wavelength of light should be substitute the values here and give me the final lambda. Chalo, jaldi jaldi. So P1 is P, so this becomes P square upon P2. P2 is 1.5 P, so 1.5 P, the whole squared is equal to lambda 2 is what we have to find. Lambda 1 ka value is lambda. Therefore, I can write this is P square upon 1.5 squared P square, which is lambda 2 by lambda. P square cancelled. Lambda 2 is lambda over 1.5 the whole square. Yeah, lambda 2 is 1.5 is 3 by 2, or we get lambda 2 is 4 by 9 times the original lambda. Okay, and the last question that we have is we haven't done de Broglie wavelength, so ये question आएगा नहीं. However, students who still want to try, we have a relation where we call as de Broglie's wavelength is given by, we will study this people in the later half of the chapter. Lambda or wavelength is equal to h upon root of 2m kinetic energy. We use this expression in the expression of photoelectric effect. Using these two expressions, you can find the answer. We will do this numerical again when we do de Broglie's wavelength. That's it. That completes numericals on, though there are many more, यहाँ पे हम रुक जाते हैं. Next class, we will first do limitations of Bohr's model, and then eventually we start with the wave mechanical or the quantum mechanical model of the atom. Thank you everyone.